What's missing from predictions? At this point, everyone has their predictions for the year, but there's no one thing that many people get wrong. Predictions are not all about narration, they are about pain and what is causing it. The industry is risk averse, and everyone wants to continue doing what they are doing. But there comes a point when it's just so painful to continue that something has changed. Having something that is 10 times or even 20 times improvement over something considered non-essential isn't worth talking about. It's likely under slow. No matter how much you speed one thing up, the total speed up is still is constrained by the bit you can improve. In my previous life as a technologist for a large IT company, I was part of the engineering team. We looked at the kinds of things that our marketing said they wanted, finding the best way to solve those issues and helping marketing and sales to be successful with it once implemented. In general, I have to say that I failed. I always was considered the eternal optimist because I couldn't understand why the ESL electronic system level design wasn't taking off. The reason that with the people had bigger issues they were dealing with. While they could see the aspect of what ESL might provide them, and it didn't help them get the current product out the door. In addition, the startup cost of a new way of doing things was often considered to only be possible if you had a substantial rate over the competition, and a failure would not mean losing your edge. Over time, I became a more part of the marketing team, trying to understand the pain level of customers and the use to what that determined well we should invest in engineering attention. Customers would never talk about it in those terms, but you had to try and find out what was holding them back and limiting progress. Of course, this always had to be separated out the bugs, which were always the most pressing pain point, and speed and capacity improvement, which required to relieve the pain, and we had to anticipate pain for the next generation product. Technically, advances are necessary, but not efficient. Region for adoption. In addition, it must have value in terms of cost, time to market, or advantageous performance. Beyond that, there has been pain. While the sounds obvious, it isn't that simple. Your tool that will add it to NRE. The cost must be recovered somewhere as well, be in another location in the flow or in area, which impacts the production cost. The amount of the cost saving must be sufficient to cover added risk. Many startups that have the forum by the wayside blame the big EDA pricing models, but all companies I know will be spent in their node it will save money. A speed improvement in one area of the flow that is not on the critical path does not alter the time to production unless the team those have finishes early can all help other areas. This is often not possible. If the improvement is made in verification, it just means that additional resources are available to lower risk. Even for verification has problems with adoption because it is difficult to put a value on finding a bug earlier in the development. And the development flow that would have been found later using edge adjusting techniques. There are some performance that matters and some that doesn't. For example, if a system is memory bandwidth constrained, there is no point of speeding the processor. Also, there is no point trying to make a standard interface run above defined performance because you lose interoperability. If you are in a closed environment, that may not matter, and absolute performance at any cost is better. Pain is a component of all of the above. It's simply said, why bother trying to improve something that nobody cares about or doesn't have defined benefit data? swamps the added risks. Without pain, if the most incredible technical advances are likely to be ignored. If the biggest and the best companies get it wrong time and time again, one EDA company publicly said for many years that the chiplets would never become popular, and then all of major semiconductor developers would continue to prefer monolithic silicon. The last part might be true, but paper became up to a great and chiplet provided relief. And the company predicted that HBM would never succeed because it was too expensive. Fast forward a few years, and HBM manufacturers cannot keep up with demand. For some markets, particularly those involved with AI, cost was not a constraint, but memory bandwidth and latency were. I see similar things going on today with the UCIe. The user base is trying to predict that pain point that they have the future and attempting to collectively solve the problem today. It's a very noble goal, and the past teams, like the International Technical Roadmap for Semiconductor ITRS, faithfully produced a report highlighting what researchers and developers should be working on today to meet the need of the tomorrow. Back to the UCIe, and while those users are perfectly placed to feel its current pain, they are nonetheless pretending to make a prediction about the future and project that the rest of the industry. The needs and pain points for the rest of the industry are very different. That doesn't mean that UCI is bad. It is a learning exercise. The standard provided guideline for IP developers to follow because without the IP, the industry cannot move forward and the IP developers cannot hope to make money. This is the only way the industry is likely to be able to overcome the pain points they have today and those they predict in the future. What we have to remember is that UCIe is a prediction and treated as such. Okay, next is here. The ARM launched its first self-made processors, poaching the employees from client report. ARM reportedly to start competing with its own customers this year. The ARM Holdings ARM is to say they launched its first in-house designed processor late this year and had already landed orders from several customers, including Meta, according to the Financial Times. The decision places ARM in a direct competition with some HP customers in the developed ARM-based processors for data centers, including the Ampere and to some degree. NVIDIA making a major shift in the company's strategy. In addition, the ARM is actively poaching the talent from its rival, according to the Reuters. ARM goes hardware. According to the Financial Times, the CPU will be a general design aimed at the data centers. It will be built on a base that allows for customization for the end user, such as Meta. The Financial Times didn't reveal the actual CPU specs or elaborate on the customization, so we can only wonder how many cores, memory channels, and PCI lanes, and other I/O the processor will support. Nonetheless, we can speculate the ARM's in-house processor will be based on the company's Neoverse V3 high performance and Neoverse N3 energy efficient general purpose cores based on the ARM v9.2 microarchitecture. It is also likely that the CPU design will leverage the ARM Neoverse Computer Subsystem (CSS) IP for the data center processors. The ARM Neoverse V3 CSS enables building processors with up to 64 V3 cores per die, while the Neoverse N3 CSS allows the building of the CPUs with up to 8 N3 cores per die. Of course, multiple CPU chiplets can be used within a processor, so the final core count of the ARM's offering remains to be seen. It remains unclear what the level of customizability ARM will offer its client. However, assuming it's substantial enough, ARM in-house CPUs will differ from the typical off-the-shelf offering from the AMD or Intel. So the ARM own data center grade CPU will, without any doubt, compete against the processors designed by its customers. However, the competition may not be dramatic as most of ARM's data center licenses use their custom design processors exclusively in their own data center. AWS, Google, Microsoft, or target them the various workloads or platforms, NVIDIA. While this division undoubtedly upset the companies like Ampere or the Huawei, it's unlikely that will cause many difficulties to Ampere appear to be in the process of being taken over the SoftBank, whereas Huawei is most concentrated on making chips for itself and close partners. Nonetheless, it will be interesting to see whether there will be many companies willing to license ARM's core design or CS's design for data center grade processor going forward. Now the ARM offer its own CPUs. So to keep in mind, the ARM and Meta did not comment to the FT on the matter and purchase talent from its customers. In addition to making its own hardware, the ARM is actively recruiting talent from its own customers, which will further elevate its client. Reuters reports the ARM has been hiring executives from its licensees since November 2023 to support its transition into chip sales. Recruiters working for ARM have contacted Silicon Valley's chip designers seeking expertise to strengthen its chip division. The hiring activity contradicts CEO Rene Haas's testimony in December in the company's trial against Qualcomm, where he denied that the ARM was building its own CPUs despite the internal recruitment efforts already being underway. Given the fact that the ARM has been actively hiring experienced chip developers and chip sales personnel for well over a year, this suggests that its own hardware is expected to become a major source of the revenue, and the company hopes to compete with the giants like AMD and Intel. Okay, next one is about NAND. The NAND flash market to grow by $26.4 billion 2025 to 2029. Boosted by the investment in production with the AI impact market trend, Technoview says. Okay, summary. This global NAND flash market size is estimated to grow by the USD 26.4 billion from 2025 to 2029. The market is estimated to grow at a CAGR of almost 6.5% during the forecast period. Growing investment for fabrication facilities is driving market growth with the trend toward the rising number of strategic partnerships and acquisitions. However, fluctuations in demand and supply poses a challenge. Key market players include ADATA Technology Company Ltd, Flexon Pte Ltd, and Greenland Systems, Hyperstone GmbH, Infineon Technology AG, Innodisk Corporation, Kingston Technology Company Incorporation, Kioxia Corporation, as Micronix International Corporation Ltd, and Micron Technology Incorporation, as Electronics Corporation, the Samsung Electronics Corporation Ltd, Semiconductor Manufacturing International Corporation, Shenzhen Rongsys Electronics Company Ltd, and Silicon Motion Technology Corporation, and SK Hynix CO, a company Ltd, and Toshiba Corporation, and Transcend Information Incorporation. Oh, there are so many, but I think this is a table. Okay, market driver. Okay, the NAND flash market is experiencing significant trend in consumption and memory packaging and fabrication facilities, and high-density storage and 3D NAND technology are driving the demand for NAND flash. and various industries such as tablets and cameras, sensors, and automotive systems, and medical devices and electronics. NAND flash memory is essential for code and AI and ML applications and consumer electronics. So NAND flash vendors are facing low supply and high demand, leading to a supply shortage and a rising cost. The industry chain is adapting to these challenges through purchase orders, optimized production strategies, and R&D. The growing demand for digital content and applications scalable storage capacities is making NAND flash memory as essential components in IoT ecosystem. So they're handling massive datasets and powering the cloud service provider. The market is also diversifying into a new market such as AR and VR devices and 8K video recording, digital health records, and medical imaging. And manufacturers are focusing on a longer development cycle, optimizing production and strategic market positioning to adapt to the cyclical market and shift and economic changes. The broader semiconductor industry is also impacted by the raw materials and production delays and environmental challenges, requiring a holistic approach to risk management and sustainable future measures. TransForce reported that production capacity utilization is high, with the chip makers and equipment manufacturers increasing production to meet demand. So the semiconductor memory market is expected to grow, with NAND flash memory remaining a key player due to its speed and reliability and flexibility. The market is also seeing the advance in high capacity and fast storage products, including SSDs and memory cards and Micron 3500 SSD, 3500 SSD, and these products cater to various industries, including the automotive applications, cloud and computing services, and 5G infrastructure. In conclusion, the NAND flash market is experiencing the demand due to the technological advancement and the reliance on the NAND flash for multifunctional communication, entertainment, and productivity tools and data processing. The industry is adapting to a supply shortage and a rising cost through the strategic production strategies, R&D, and eco-friendly measures. The market is expected to remain a crucial component in the electronics sector, handling massive data sets, powering cloud computing industry infrastructure, and enabling diverse application in various industries. The NAND flash market is witnessing an increase in strategic partnership and acquisitions and enabling vendors to expand their market presence. These collaborations allow companies to develop technical initiatives such as joint development of 3D NAND flash memory and make capital investments according to the market trend. For instance, the Micron Technologies partnerships with 7 industrial companies in February 2020 aims to deliver an innovative solution for industrial applications and including the factory automation, transportation, and defense systems through the Micron IQ Partner Program. This collaboration strengthens the competitiveness of the involved parties and advanced in the development of the high-quality and long-lasting NAND flash product. The market challenges. The NAND flash market is currently facing several challenges that are impacting both chips and facing equipment manufacturers. NAND flash consumption is growing rapidly due to the increasing demand for high-density storage in various industries such as tablets, cameras, and sensors, automotive systems, and medical devices and electronics. Thus, this demand is driving the need for more advanced NAND technologies like 3D NAND and larger capacities in TLC segment, SLC, and MLC variants. However, the production capacity utilization is low due to supply shortages and rising cost. The industry chain is facing the purchase orders that exceed supply, leading to price erosion and reduced profitability for NAND flash vendors. This situation is further complicated by the cyclical market shift, economic changes, and supply chain constraint. Moreover, the technological advancement in areas like AI, ML, and cloud computing infrastructure require faster and more reliable and scalable storage capacities. Modern consumers rely on NAND flash memory for the web browsing and email loading and games and social networking sites, 5G wireless communications, and multifunctional communication devices. NAND flash memory is an essential component in the diverse industry, including AR, VR devices, accurate video record, digital health record, and medical imaging, and wearable devices, innovative city initiatives, and environmental monitoring systems. So, as a result, NAND flash memory vendors must diversify their product and optimize the production strategy to meet the growing demand and handling massive data sets in data centers and cloud services providers. To address these challenges, NAND manufacturers need to adapt to the cyclical patterns of the semiconductor memory market, invest in R&D, and implement longer development cycles to stay competitive. They must also focus on optimization production and reducing production costs and managing risk and through strategic market positionings and adaptive production strategies. The broader semiconductor industry is also facing the challenges including the raw materials, production delays, and increased cost and environmental challenges and sustainability concerns. NAND flash memory vendors must address these challenges to ensure a sustainable future and eco-friendly measures in the industry. In summary, the NAND flash market is facing the significant challenges due to the growing demand and supply shortages, rising costs, and technological advancement. The NAND flash memory must adapt to these challenges through innovation R&D and strategy to the challenges through the innovation and R&D and strategic market positioning to maintain their global market dominance and meet the demands of the industry enterprise use and storage solution provider. The NAND flash memory market experienced a significant challenge due to the widening demand-supply gap. This is arises from the cyclical nature of the semiconductor industry, which affects the production of the NAND flash. The market relies on the demand on industries and smartphone and data centers, diverse servers and the cloud storage and the consumer electronics. Vendors attempt to align production with the sales in these sectors, but unexpected changes in the demand that can result in oversupply and shortage. The dynamic semiconductor industry, influenced by the customer electronics design function, emerging the technology and manufacturing process challenges, contribute to the persistent supply-demand imbalance. So, the smartphone. Global NAND flash market is experiencing growth due to several factors. The increasing the penetration of the internet and the widespread use of the low-cost smartphones are driving the generation of large volumes of data, including audio, video, text, and encrypted blocks. So social media applications such as Facebook, WhatsApp, and Instagram are popular among users, leading the storage of vast amount of data by these companies. The adoption of higher resolution camera modules in the smartphone and capturing for selfies and recording the video is also contributing to the demand of the NAND flash. The implementation of 4G and 5G networks, such as use of smartphone applications, are further increasing the volume of the data generated by and stored in a smartphone. Technavia expects smartphone manufacturers to incorporate multiple lens camera systems, leading to the increased demand for the high-capacity memory modules. All these factors are expected to fuel the growth of the NAND flash market during the forecast period. The research analysis. NAND flash consumption continued to soar, driven by the insatiable demand for high-density storage in the consumer electronics. Memory packaging and fabrication facilities are working at a full capacity to meet this demand and focus on 3D NAND technology to increase storage density. Edge storage and high-density data centers also contribute significantly to NAND flash market growth. Chip makers and equipment manufacturers collaborate to ensure the Citi, a supplier of NAND flash memory, but the industry faced challenging balance between the low supply and high demand. TrendForce reported the production capacity utilization remains high, though reflecting the reliance on the NAND flash memory in modern customer devices such as tablets and cameras. Technology advanced in the NAND flash memory are expected to further fuel demand, making it a key player in the semiconductor memory market. So the market research overview. NAND flash consumption continued to soar in the electronics devices sector, fueled by the growing demand for high-density storage and 3D NAND. Memory packaging and fabrication facilities are working at full capacity to meet this insatiable appetite for flash memory. As NAND flash is increasingly used in tablets, cameras, sensors, automotive systems, and medical devices, processors, and various digital applications. Modern consumers are relying on NAND flash memories for web browsing and email loading and social network sites, 5G wireless communication, and more. The semiconductor memory market, led by the NAND flash, is expected to grow due to the technological advance and the increasing importance of storage in diverse industries. The TrendForce report that the production capacity utilization is high, leading to the supply shortage to a rising cost for NAND flash. The industry chain is facing the challenges due to the low power, to the low supply and the high demand, which has impacted the purchase orders, causing an industry-wide interruption. NAND flash memory is an essential component of cloud service providers, handling massive data sets and offering speed, reliability, and flexibility. Advanced in storage capabilities for performance driving innovation and development in the core and semiconductor industry. The NAND flash market is cyclical with economic conditions since exposure becomes and market demand influencing its pattern. NAND manufacturers are diversifying for the product and optimization production strategies to adapt to cyclical market shift and economic changes. Despite challenges such as supply chain constraints and natural disasters and global events, and the future NAND flash looks promising a focus on sustainability, eco-friendly measures, and longer development cycles. The market is expected to continue its growth trajectory, driven by the increasing importance of storage in various industries and its need for scalable storage capacities. About Technavia. Technavia is a global technology research and advisory company. The research and analyst focuses on emerging market trends and provide actionable insight to help business identify the market opportunity and develop effective strategies to optimize their market proposition. Okay, thank you. Thank you for your time and see you next time.